So here we have the function y equal to -2 cosine of 4/3 x plus pi over 3 plus 3, and we want to graph it. So we're going to find the usual things. The amplitude is 2. Also, we should notice, right, that negative out in front here means we're going to have a vertical flip. So usually cosine of x would look like this. It'd start high and then it would go down. Right? It'd be like high, middle, low, middle, high. That's what cosine would usually look like. But since we have a negative cosine of x, we know that it's going to look like bottom, middle, high, middle, bottom. Like that. So we know what the shape should be. And this isn't exactly a graph, but it's kind of good to think about, okay, yeah, we know we're going to look like that. And we know that our vertical shift is going to be up 3. So that we start drawing coordinate system. I don't know what my horizontal shift is exactly yet, but I do know that it's going to be to the left. So we know we're going to start somewhere over here. And our vertical shift is going to be up 3. And then our amplitude is going to be 2. So from y equals 3, we're going to go as high as 2 above, as low as 2 below. So in fact, if someone wanted to, they could ask you, and you could easily answer a question about the range without having to do any graphing. So if someone said, just as an aside here, what's the range? We can write it up here. The range of this function, well, the function goes as low as 1 and as high as 5. So the range would be inclusive 1 to 5. And that's something you can always answer about a sine or a cosine function without doing any graphing. Just be like, oh, the middle point's 3. We go 2 above and 2 below, so we're going as high as 5, as low as 1. That could job. Okay, the vertical shift is up 3. Our horizontal shift, we're going to find by setting the insides equal to 0. So it's going to be 4/3 x plus pi over 3 equal to 0. I'm going to isolate x. So I'm going to get 4/3 x equal to negative pi over 3. And then we're going to multiply both sides by the reciprocal of 4/3, which is 3/4. So x is going to equal 3/4 times negative pi over 3. The 3's cancel, and you get negative pi over 4. So my horizontal shift, my starting place, is negative pi over 4. Okay, let's find our period. So the period is going to be 2 pi divided by what? Anybody want to venture a guess?
Would it be 4/3 x plus pi over 3?
Not quite all of that. So we're dividing by just a number, not a variable. It's just the 4/3. So whenever you're finding the period, it's always going to be 2 for sine or cosine. It's always going to be 2 pi divided by whatever is multiplying x. So that part right there. So then we want to simplify this. So when we divide by a fraction, you're going to flip and multiply by its reciprocal. So this is equal to 2 pi times 3 over 4, which is 6 pi over 4, which is 3 pi over 2. So that's our period, 3 pi over 2. Okay, so then we want to find a fourth of that because, again, right, the whole idea of finding this is we're going to basically say we're going to do a quarter of a period. So assuming I've got the length right, which is kind of a guess, quarter, 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 and a quarter. Right, so this is going to be our whole period. And you don't have to draw this. I'm just trying to show you guys what's happening here, right? This is going to be one whole period. Each of these lengths is a quarter of the period. So typically, if I was actually doing this problem like on a test, I would probably do the following. Wouldn't write all this, but I would label this point as x2, this point as x3, this point as x4, and this point as x5. And then I would go find them somewhere that's kind of giving me a little bit of space. And this one is x1, which we've already found. So x1 is your starting place. Oh, sorry, I need to find 1/4 of my period before I found this. So 1/4 of my period is 1/4 of my period, 3 pi over 2. And 3 pi over 2 times 1/4 is going to be 3 pi on top, 8 on the bottom. Okay, so now we're going to take our starting place, which is x1 equal to negative pi over 4. And to find each subsequent spot, we're just going to keep adding a quarter of our period. So the second important point, x sub 2, is the first spot, negative pi over 4, plus a quarter of the period, which is 3 pi over 8. We need a common denominator. Negative pi over 4 is negative 2 pi over 8. So that's negative 2 pi over 8 plus 3 pi over 8, which is going to be 1 pi over 8. So there's your x2, there's your x1. So if you look at my picture, it looks all right, but maybe I should have been spaced out a little bit further to the left here. It's okay. The spacing doesn't have to be exact, but it should, right? The reason I'm saying this is, right, x1 is negative pi over 4, which is negative 2 pi over 8, and x2 is pi over 8. So it should be more to the left than it is to the right of the origin. Not a huge deal. And then my next point, x3, is going to be previous point, pi over 8, plus a quarter of my period, which is 3 pi over 8, which is going to be 4 pi over 8. You don't have to reduce this, but you could if you wanted to, but you shouldn't. The next point is going to be the previous point, 4 pi over 8, plus 1/4 of the period, which is 3 pi over 8, which is going to give you 7 pi over 8. And finally, the last point, x sub 5, is going to be the previous point, 7 pi over 8, plus 1/4 of the period, which is 3 pi over 8. Oof. Attacking myself with a pen here. Which is going to give you 10 pi over 8. And again, I think if you write them down here and just write x1, x2, x3, x4, and x5 on your x-axis here, that's perfectly fine.
James?
Yes.
For x2, can you explain one more time why we added 3 over 8 twice?
I didn't add it twice. So for x2, I started with x1 being negative pi over 4. I added 3 pi over 8, and then I rewrote it. I multiplied negative pi over 4 by 2 over 2.
Oh.
Pi over 8 plus 3 pi over 8.
Sorry, I misinterpreted.
It's all right. You should always clarify. So then we're going to graph this cosine function. And usually, cosine would start at our first x value at the top. But since it's the flip of cosine, it's going to start at the bottom. Now be careful. It can be really, really tempting to make a mistake here and start at the bottom right there. That's not where we're starting, right? Because we're not starting at x equals 0 or x1 equals 0. We're starting at the first important x value being negative pi over 4. So we're starting right here, right where the x value is negative pi over 4 and the y value is 1. And then at the next important x value, we're going from the bottom to the middle. And then at the next important x value, we're going from the middle to the top. And then the next x value back to the middle. And then the next x value back to the bottom. Now, you should try and make this look like cosine, right? So it might be tempting to kind of like just draw like a pointy kind of absolute value looking thing, but it's got to have some curve to it, right? Cosine should be a nice curvy function. It should be a sinusoidal looking, right? That's the official name. It's got the usual sine or cosine curve to it. And it doesn't have to be perfect, but it should look decent. Remember, right, when you're getting close to this bottom, you should actually be bottoming out and then turning around. I've seen a lot of people, not in this class, but just in general, I've seen a lot of people accidentally like get here and be like, okay, there's that, and they're like, oh, we gotta turn around. That's right, this point here should be the bottom. You should be going lower than it. So that's gotta be like that, right? That's gonna be where we bottom out. Is it best to use our usual reference points as our values on the x-axis and then base our calculated values on that? By usual values, do you mean 0, pi over 2, pi, 3 pi over 2, and 2 pi?
Yeah.
I would say no. I would say it's best. So I probably got a little bit ahead of myself and started plotting the x points before I knew them. What I would say is probably best to do. I mean, actually, I guess I'm not sure. Maybe I'm mishearing your question. So if I think about what your question is actually asking, I think what you're asking is it best to use those 5 values and think about kind of like the y coordinates? And to that question, the answer is kind of yes, right? We're finding the points on the unit circle that are the different corners of the unit circle, so that we're getting cosine. So let me give it a little bit deeper of an explanation here. What we're really doing, so I'm going to erase some of this to kind of make room for what we've got here. Here's what we're really doing. We're really using the fact that we want the angles to be those values. We really, really want our angle, and I'm going to call it theta for a second. We really want theta to be 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. Because we know that cosine of those values, right? Cosine of theta, cosine of 0 is 1, right? We can use the unit circle. And we know that the angle 0 gives you a cosine value of 1, and then pi over 2 gives you 0. And then cosine of pi is negative 1, right? Cosine of 3 pi over 2 is 0, and cosine of 2 pi is back to 1. Okay, I don't have enough room. That's the problem. So let me erase and I'm trying to make this work. Okay. So I want column there. I think this will work. Okay. We'll see. So here's theta and cosine of theta. Usual values, right? Theta is 0, pi over 2, pi, 3 pi over 2, 2 pi. Cosine of theta is 1, 0, negative 1, 0. Or as I often think about it, high, middle, low, middle, high. But then I took my cosine and I multiplied by negative 2 and then added 3. So negative 2 cosine of theta plus 3, well, negative 2 times 1 is negative 2 plus 3 is 1. And then negative 2 times 0 plus 3 is 3. And then negative 2 times negative 1 is 2 plus 3 is 5. And then negative 2 times 0 plus 3 is 3. And then negative 2 times 1 plus 3 is 1. So notice, right, this is giving me my correct range. It's giving me the low, middle, high, middle, because we flipped it over. We also did a vertical shift and amplitude stretch. Okay. But these aren't the angles we used. And the reason why that's true is because your angle here, theta, is 4/3 x plus pi over 3. But we actually have to, we're not graphing theta, right? This is not the theta axis, this is the x-axis. And so what we're actually, so the process that I'm having you guys do, where you find your starting place, and then you find your quarter of your period, and you add that 4 times to get your different values, that's the same as what you would do is if you were trying to take these angles and solve for x. I think I'm going to erase this now so I can show you guys this work. Yeah. Sorry, I know. Really looking forward to the day where I have like all the board space in the world to write down all this stuff. I'm going to leave those there just so we can compare them to what we get. So here's what I've got. I've got 4/3 x plus pi over 3. And I want it to equal these 5 usual angles, right? The 4, but really 5 corners of the unit circle. Right? These are the angles we always use. But the problem is x isn't the angle. Whatever's inside your trig function is the angle that we're taking cosine of. So if I set this equal to 0, which we already did the work, I'm going to do it again, we're going to get 4/3 x equal to negative pi over 3, and then we multiply both sides by 3/4 to get x equal to negative pi over 3 times 3/4, which is negative pi over 4. So x has to be negative pi over 4 for the first thing we take cosine of to be cosine of 0, which equals 1. Okay. And then what we usually do is we just say, okay, then I'm going to keep adding 1/4 of my period, because that's the whole idea, right? Usually, if the period was 2 pi, we'd just be adding 1/4 of 2 pi to get all those values. But our period's not 2 pi. So let me show you how the work would work if we did it the hard way. I want my angle to be pi over 2. So I'm going to set my angle equal to pi over 2. So I'm going to set 4/3 x plus pi over 3 equal to pi over 2. So now I have to solve for x. Okay, so let's see. I'm going to do 4/3 x equals pi over 2 minus pi over 3. I need a common denominator. So 4/3 x equals 3 pi over 6 minus 2 pi over 6, which is pi over 6. Then multiply both sides by 3/4 to get x equals 3/4 times pi over 6, which is 3 pi over 24, which is pi over 8, which, if you recall, was our x2. Right? This is totally negative pi over 4 is our x1. Pi over 8 is our x2. Let's do one more at least. So define the, so pi over 8. Define the next one, you would set your angle equal to pi. So, right, setting 4/3 x plus pi over 3 equal to pi. I'm going to subtract pi over 3. Pi minus pi over 3 is 2 pi over 3, just like 1 minus 1/3 is 2/3. So you get 4/3 x equals 2 pi over 3, right? Because pi minus pi over 3. Multiply both sides by 3/4 to get x equal to 3/4 times 2 pi over 3. The 3's cancel, and the 2's cancel to give you pi over 2, which is the same as 4 pi over 8. So the whole idea behind this process, and I'm not going to do the rest of it because they will be, so they will end up being 7 pi over 8 and 10 pi over 8. All might show up as 5 pi over 4. But the whole idea is that we want these to be the angles. So we're finding the correct x values so that when you plug in those correct x values to x, the quantity inside the trigonometric function is 0 or pi over 2 or pi or 3 pi over 2 or 2 pi, so that you get these values for cosine and then the corresponding values for the actual function. So that's why all of our angles are 1/4 of a period apart from each other, because when we do the multiplying and the adding, really just the multiplying, it ends up giving you angles that are all 1/4 of the usual 2 pi period apart from each other. So I know it's a very long answer to your question, but yes, the idea is that we're kind of in the end looking for these values, but we don't actually use these values, right? So even though these values play a role, they don't actually show up in our graph ever, unless our period is actually 2 pi to begin with. I mean, they could show up occasionally, but typically, right, we're just saying, okay, take your period, divide it by 4, find your starting place, which is negative pi over 4, and then just keep adding 1/4 of the period 1, 2, 3, 4 times to get all 5 of your values, right? Because you're starting here, and then you're adding 1 time to get the second value, second time to get the third value, third time to get the fourth value, and you're adding a 4th time to get the third value. Okay, so
Thank you for that. That was a super long explanation, but it helped a lot.
good, yeah.
Yeah, because I thought that we had to, like, I don't know if all the time, but at least sometimes, like, compared to the usual sine and cosine graphs. So that's what I was doing, but
Sure. I mean, I would say the answer is no. You don't have to. I mean, it's kind of always. The answer is yes and no. The answer is yes. You're kind of always doing it because you can't not, right? The graph, the thing you're graphing is cosine or sine, so it's always in some way being compared to the original sine or cosine graph. But the more direct answer is no. You don't have to draw like the original sine or cosine function and see like how this compares to that.
right.
The question that's really being asked is to just draw this thing. So let's do another example. Let's try and do the minimal amount of all the work, meaning we're going to show all the work we need to show and kind of nothing extra. I suppose I should make something up. Let's do y equal to 2 sine of, I have to make something up that's going to be not terrible there, plus 1, and let's make it, sorry, let me take just 1 second. 2x plus pi over 3. Okay. It's not too terrible in the world of these. So let's do the usual things. And let's go ahead and let's just start finding the x things, because that's the hardest part typically. So our period here is 2 pi divided by 2, right? Because of this 2 here. And that's where that's coming from. And then that's going to equal pi. 1/4 of our period is going to be 1/4 times pi, or just pi over 4. Important x values. Okay, we need to find the starting place. The starting place is your horizontal shift. Which I think is easiest to find. That's a good question, Jesus. So let me answer that. So here's why. What's a normal period?
2 pi.
Right, for sine or cosine. So the idea is that you're going through one full unit circle, one full revolution. So if I was graphing y equal to sine of theta or y equal to cosine of theta, the angle theta has to go from 0 to 2 pi. Okay, so which is this, right? 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, let's say I'm going to pick a different thing here, but then we'll come back to this one. Let's say I was graphing, I don't know, y equal to cosine of 3x. Okay, well, my angle isn't x. My angle is whatever. So I know it's weird to call this an angle because it's a variable, but I'm always thinking that the thing I'm taking cosine or sine of, right, we only take sine functions or cosine functions or trig functions of angles. It doesn't make sense to take a trigonometric function of anything that's not an angle. So the thing that's inside the trig function is an angle. So that angle is what we're taking cosine of. And we know that we want to get one full period. We want our angle to go between 0 and 2 pi. So our angle, which is 3x, has to go between 0 and 2 pi. Okay, but again, when I graph this thing, I'm not graphing 3x on the x-axis. I'm not graphing theta on the x-axis. I'm graphing x on the x-axis. So even though I know what the angle has to be, when I'm graphing it, I need to know what the x values are. So if I divide everything by, the coefficient of x, I'll figure out what x has to go between. Well, 0 divided by anything that's not 0 is 0. Now I'm running out of room here. 3x divided by 3 is x. And 2 pi divided by 3 is 2 pi divided by 3. So look, the period for this cosine of 3x is between 0 and 2 pi over 3. So the period has a length of 2 pi divided by, the coefficient of x. And that's the same thing here, right? And I can show you a little bit more work here. I need 2x plus pi over 3 to go from 0 to 2 pi. Well, I don't really want to deal with the pi over 3, so I'm not. I'm just going to divide everything by 2. So I divide everything by 2, the coefficient of x. 0 divided by 2 is 0. 2x divided by 2 is x. Pi over 3 divided by 2, I don't really care, but I will tell you it's 1/2 times pi over 3, which is pi over 6. And 2 pi divided by 2 is pi. Well, look, to get one full period, this thing here has to go from 0 to pi. Or I could even subtract the pi over 6 and say negative pi over 6 is less than or equal to x is less than or equal to pi minus pi over 6 is 5 pi over 6. But subtracting the same thing from each part of the inequality didn't change the length of the period. Right? 0 to pi is still the same length as negative pi over 6 to 5 pi over 6. It's still a length of 1 pi. So that's why we divide by the coefficient of x, because that's going to tell us how long the period needs to be.
Okay, thank you for that.
I'm happy to. It's a good question. So, also, I will point out, if you look at this, it actually does show you what the starting place is, right? So even though I don't think you should do it this way, looking at it this way, we can see that we're going to start our graph at negative pi over 6, and we're going to end our graph at 5 pi over 6. And we found the starting place literally by setting the insides equal to 0 and then solving for what x had to be equal to. So when we graph this, I'm going to erase this part, but when we find this, we're going to find that our x1 is negative pi over 6, and our x5, the last one, is going to be 5 pi over 6. Oh, I picked an example that I don't love. That's fine. I just don't want to. I don't want to make you think it's going to be that easy. No, okay, that's fine. I'm not. I'm crazy. Sorry, that's fine. Never mind. I'm off base. This is a perfectly fine example. It's not as easy as I thought it was going to be. Okay, let's find the starting place again. The most direct way of finding the starting place, I think, set the angle, which is 2x plus pi over 3 to 0. Because, right, the angle we want to start at is 0. And then, right, we find the other 4 x's that correspond to those angles. So, let's see. 2x equals negative pi over 3. divide by 2 or multiply by 1/2, x equals 1/2 times negative pi over 3. So we get the first x value is negative pi over 6. Okay, to find the rest of them, we're going to add on a quarter of the period 4 times. So x2 is going to be the previous spot, negative pi over 6, plus the 1/4 of my period, which is pi over 4. You will have to get the common denominator most of the time here. Typically, the least common denominator is what you want, which is going to be, let's see, the least common multiple of 6 and 4 is 12. Multiply this by 2 over 2, this by 3 over 3. So you get negative 2 pi over 12 plus 3 pi over 12. It's also worth noting at this moment that 12 is going to be the denominator that's going to work the best for us for the rest of these values. So you're going to want to remember that your period divided by 4, 1/4 of your period, is the same as 3 pi over 12, because that's what we're going to add on every time. Negative 2 pi over 12 plus 3 pi over 12 is 1 pi over 12. So that's our x2 value. To get the next value, we take our previous value, pi over 12, and we add on 1/4 of our period. But we already know 1/4 of our period is 3 pi over 12. So then pi over 12 plus 3 pi over 12 is 4 pi over 12. And yes, I know we could reduce that to pi over 3, but I don't want to. The fourth value, x4, is going to be the previous value, plus, again, 1/4 the period, which is pi over 4, or easier, 3 pi over 12, to get 7 pi over 12. And finally, the last important x value, I'm going to erase all this. Probably can put this all on this side. So the last value is going to be x sub 5, is going to be the previous value, plus my 1/4 of my period, which is 3 pi over 12, which is going to give me 10 pi over 12. So those are my important x values. And when I graph this thing, I often like to ask questions where the horizontal shift is to the left. And then usually the next point is to the right. So my first x value is negative pi over 6. My second x value is positive pi over 12. So let me ask you. So which one is further away from the origin? Negative pi over 6 or pi over 12? Which is the, if you ignore the negative sign, which one is the bigger number? Pi over 6 or pi over 12?
Would it? You can go ahead.
Never mind. Oh, wait. No, you can go.
Pi over 6?
Exactly. Smaller denominator, bigger fraction. In fact, pi over 6, or negative pi over 6, is negative 2 pi over 12. So it's literally, if you ignore the negative, twice as big as pi over 12. So when I'm graphing this, I'm going to try and make this first point negative pi over 6, and the second point pi over 12. I'm going to try and make the negative pi over 6 kind of twice as far away from the origin as the pi over 12. It doesn't have to be exact, but it should be evident that this point is further from the origin than this point. So you should think about the relative sizes of things. And then you should try and make it not be super huge, because, so like I'm going to do this first. So maybe there's my x1, which is pi over 12. And then that distance, I'm going to double it. And I probably went a little too big, because then this is a 1/4 of my period from x1 to x2. And the rest of my quarters of my period should be the same length. Sorry, from here to here to here to here. Okay, it kind of fits. But again, right? If they're not all exactly the same length, that is, I mean, they can't be exactly the same length, but they should look pretty close, right? They shouldn't be wild variations in how far apart these 5 points are. because they're all exactly the same length apart. So they should look like they're pretty close to being the same length apart. And again, I'm going to label them easily, right? I already know what x1, x2, x3, x4, x5 are. I don't need to write those values again because it's kind of a pain to scrunch them in there. Depending on your writing, right? On the board, and also just my writing is not the best. If you find that you want to write them in there and you have nice, neat handwriting, do whatever is best. But if you write the values somewhere down here and you've labeled them correctly, right? You said, oh, x1 is this one, x2 is that one. Then writing those values up there like that. Okay. The amplitude's 2, the vertical shift is 1. So the vertical shift is up 1. So we know our new middle line is 1. Now, I don't think your x and y axes need to have the same scale. I will mention that this x2 value is pi over 12. Pi is around 3, so pi over 12 is around 1/4. So that's 1/4, right? Then my 1 would have to be like there. I'm not going to do that. My x and my y scales do not have to be the same. So do whatever is convenient. Do whatever makes it so you can actually graph the thing and not have to draw a gigantic graph. So let's see, I know my vertical shift is up 1. Let's say 1's about right there. And then I'm going to go 2 above, because my amplitude is 2, and 2 below. Okay. So now we have to graph the thing. Sign starts in the middle, right? On the unit circle, sign goes 0, 1, 0, -1, 0, or middle, high, middle, low, middle. So sign starts in my new middle. Okay, be careful. The next point's high, but it's not right there. It's right there, right? It's at your next x value, the corresponding high y value. And then your next point is back in the middle. So at the next important x value, we're back in the middle. At the next x value, we're back at the, or we're at the bottom. Now, again, another thing people often kind of can make an error with is sometimes they're like, oh, the next x point should be on my x-axis. We don't normally get the x-axis unless we have, really unless we haven't shifted up or down, or the amount of shift up or down is the same as the amplitude. That's not the point we want. We want the point that's down at the bottom, right? We start at the middle, went up 2, went down 2, went down 2, and then we're going to go back up 2, back to the middle. And then we try to do our best graph we can. So let's see, signs and look like this. It doesn't have to be perfect, but it does have to have the right shape, right? It has to top out here. It has to bottom out here. Questions about this?
I don't know if it's the correct question, like the way I'm gonna phrase it, but is it okay if our graph is like, if it looks kind of weird, because the pi over 6 is like, I guess, more far back, so it's gonna have like a longer tail at the, like where it begins. I don't know if that makes sense.
Longer tail.
Like there's gonna be more distance between the x values, I guess.
So there shouldn't be more distance between the x values. So each of these x values should have the same amount of distance between them.
Okay, that was my question, I guess.
So when I'm graphing this, I'm kind of thinking about how basically each quarter of the graph is essentially the same piece of the graph, just reoriented. So this first quarter, I've got this piece of the graph, which I know I haven't drawn right. This next quarter, I've taken that piece and I've reflected it over. So now it looks like this. And then this next quarter, I've taken this piece and I've reflected it over and over. So then it looks like that. So again, my picture, not the best. But if I actually kind of talk more about it, I can make it look a little bit better. And then my next quarter, I've taken this piece and reflected it over. So each quarter actually is the same piece, just in a different orientation. It's also true for cosine, which I erased that picture. Sorry. I can draw you a cosine one though real quick, just to kind of show you. It's literally the same deal. So if you're doing a cosine, and I don't know, we were doing cosine of, I think it was, I don't know, it doesn't really matter. But let's say, right, let's just make it easy and start with the origin. Let's say we've got an equally spaced out thing. Maybe it's going as low as 1 and as high as 5, like the previous one was. Right? For cosine, if it was, well, it was negative cosine. So I was starting at the low, and then the next important point, I was at the middle, and then at the top, and then back to the middle, and then back to the bottom. And again, this is something like y equal to negative 2 cosine of, I don't know, something times x. Let's just say x. Let's make the period 2 pi plus 3. Right, so this is, but then each piece, right, this first quarter of it, right, has this kind of order. And then I'm just taking that piece and I'm flipping it up and over to get, all right, this section here and this section here literally are the same shape. It's just, it's been kind of rotated up over there or flipped and flipped. And then to get the section from here to here, it's just this piece, but reflected over. So it looks like that. And then this piece from here to here is this piece reflected over that. Or you can even think of it as this piece being brought over there, but reflected. So each quarter does look the same, just in a different orientation. In fact, you get one of each orientation, which is kind of interesting. I generally don't recommend making a table because you really, I mean, if I guess I should say, you should probably do what's best for you. So if making a table is going to make it better for you, then you should do that. Also, there probably, I imagine there is a lot of time during the final, so it's probably going to be, you probably have enough time to do that. But personally, I think it is most efficient to do what we've done here. And again, right, you are, not the deficiency is always what we're shooting for, but in an exam, there are, even if there's a lot of time, there are still time limitations. You can get the x values from, I think you mean the y values, Paula. I think. Right, we're getting the y values. So the vertical shift is 1, and then the amplitude is 2. So we're doing, right, we're starting for sine in the middle at 1, and then we're adding the amplitude to get to 3, and then we're subtracting the amplitude to get back to 1, subtracting, adding. Another way I think about these graphs is that you're always going where you weren't, meaning sine starts in the middle, and then we have to go to the top if it's usual or the bottom if it's flipped. So we go from the middle to the top. And then once we're at the top, we can't go any higher, so we have to go back to the middle. And then when we're in the middle and we were just at the top, we can't go back to where we were. We have to go to the other place, which is the bottom. And then from the bottom, back to the middle. So it's always middle and then where you weren't. So middle, top, middle, and then bottom. And then middle, top, and then middle, bottom, right? It's middle where you weren't, middle where you weren't, middle where you weren't. Same thing for cosine. Start at the bottom for this reflection of cosine, the slope of cosine. So bottom and then middle, and then where you weren't, which is the top, and then middle, and then where you weren't, which is the bottom. So you're always kind of going back and forth. But the x values will have to be the phase shift as the first value, and then dividing by 2, and then getting the averages in between. That is not the way I would interpret it. The way I'm thinking of the x values is by finding the first x value, which is the phase shift. That part is correct. But then the rest of the x values you're getting by finding a quarter of the period. And so again, the period is In this case, your period is 2 pi divided by 2, but it depends on what that number is, right? Your period is 2 pi divided by whatever the coefficient of x is. And then you're taking that period, which is pi in this case, dividing that by 4, and then adding that on to your phase shift to find each of the 5 important x values. So I don't think there's any kind of averaging there. It's just taking your period, dividing it by 4, adding that on to the x value 1, 2, 3, 4 times to get a total of 5 x values. But just be aware, right? Your period totally depends on the coefficient of x there, right? And so I could totally see on the final asking you guys some questions like, for example, just kind of make sure it's very clear. What's the period of these 3 things? The period of y equal to cosine of 6x, y equal to sine of 3 pi x, this one's kind of annoying, or y equal to tangent of 5x. Okay, so for this one, the period would be 2 pi divided by 6, which is pi over 3. And then if you were actually graphing it, you would take pi over 3, you divide it by 4, you would get pi over 12, and that would be what you would add to each thing to get the next pi value. For this one, we haven't seen something like this really, but the period here would be 2 pi divided by the coefficient of x, which is 3 pi, which is 2/3. That's kind of a strange period for a trig function, but if you're just finding period, it would be terrible. And then finally, this one for tangent, the period would be, now remember for tangent, it's not 2 pi divided by the coefficient, it's just 1 pi divided by the coefficient. So the period here would be pi divided by 5, and that's it. So for sine and cosine and secant and cosecant, the period of your function is 2 pi divided by whatever is multiplying x. For tangent and cotangent, the period is pi divided by whatever is multiplying x.